Hi everybody, so today we're going to be starting a new topic. It is section 7.1 in your book, and this is our first section of Unit 6 that we're going to be going over. So I know it's Unit 6, but Chapter 7. So it is adding and subtracting polynomials. I use the symbols to abbreviate it, but if you want to write out the full word, adding and subtracting, that's totally fine. Go ahead and pause this video and write down all of these definitions real quick and leave a little bit of space where I have the example shown, and leave a space underneath each of these as well. All right, let's go ahead and go over our definitions. So first up is like terms. This is when two monomials that have the same variable and exponent, and we'll go over what a monomial is in just a minute. But some examples of like terms would be like, say, 3x and 2x. Those are like terms because they both have just an x. Or another example would be, say, 4y squared and 7y squared. These are both a y squared term, so they are like terms. Something that's not like terms would be 3x and 3y. These would be not like terms. Even though the 3's are the same, it's an x and a y, so they are not like terms. Next definition is something called standard form, which I'm sure many of you have heard of before. This is writing the largest exponent first, or in other words, writing them in order from largest to smallest exponent. So say, for example, we had 3x squared minus 2x plus 1. So this is in order with the highest exponent first, and then it goes in order from there. So the highest exponent, then the x term, and then the constant that has no x attached to it. All right, let's look at our next set of definitions now. Types of polynomials. So this is where we're going to see what a monomial is. So a monomial just means it has one term. So this could be something like, say, 5x squared y. Even though it's a bunch of different things, it's still only one term because there's no addition or subtraction in between those things. Oops, hang on. All right, there we go. Then a binomial. A binomial means it has two terms. So that could be anything with addition or subtraction in between. So let's say we had 3xy minus 4. This has two terms. First term, second term. Then a trinomial. Think of like tricycle. A tricycle has 3 wheels, so it has 3 terms. Same with a binomial. Bicycle has 2 wheels. Binomial, 2 terms. That's what those prefixes mean. Monomial, mono, that prefix means 1. So trinomial, 3 terms. Let's say, for example, we have x squared minus 3x plus 5. We have 1 term, 2 terms, 3 terms. They're combined together with pluses and minuses. And then anything with more than 3 terms, we just call it a oh my gosh, I can't talk. We just call it a polynomial. So if it has 4 terms, 5 terms, 15 terms, anything more than 3 terms, we just call a polynomial. All right, last couple definitions. I know it's a lot of definitions up front. This is really, really going to help you out this whole unit. All right, next definition is degree. This is the highest power in all monomial terms. So let's say, for example, we have 3x plus 4x cubed. The highest power is the highest exponent. So let's look at, sorry, I was grabbing a highlighter real quick. My highest exponent is the 3, which means the degree is 3. Now let's look at the next one. So this one is a little bit different because we have x's and y's. So our exponents on the x, there's a 2 and then a little invisible 1. So that gives us a total of 3. And then the next term, I have an exponent of 2 and an exponent of 4, which gives me a total of 6 if we add those together. So for this one, this is degree 6 because that is the highest power. All right, now our last definition, leading coefficient. This is the coefficient, or in other words, the number. I'll write a little note. The number of the monomial with the highest degree. So if we look at this one, 4x cubed plus 3x minus 7. The highest degree is 3. And that leading coefficient that's in front of this term is the 4. So my leading coefficient is 4, and I'm going to abbreviate that as LC. Now my next one, this one's a little bit trickier because it's in a different order. So I have an x cubed, and an x squared. Which one is the highest power? Good, you should have said the 3. 3 is the highest power, which means whatever number is in front of this term is our leading coefficient, which is the negative 2. So even though it's not the first term that's written, it's still the term, or it's still the coefficient in front of that highest power. Now we could also rewrite this in standard form, writing that negative 2/3 x to the third, or sorry, negative 2x to the third first. So if we rewrote this in standard form, that would be negative 2x cubed plus x squared plus x. And now it's easier to see that this is our highest power and negative 2 is the leading coefficient. All right, now that we've gotten all the definitions out of the way, let's actually start to apply this. My apologies that this big giant chart is written out. I was starting to make a PDF to upload for you guys to print, but my printer is having lots of issues and prints a big giant streak, black streak down the middle of the page. So I can't print anything to write your notes on. So unfortunately, we have to do it like this for today. But in this chart, we have the expression that we're given. I want you to label what type of polynomial it is, what degree it is, and what the leading coefficient is. So I'm going to do a few of these with you and then have you fill in the rest. So the first one has 3 terms. So since it's 3 terms, that means it is a trinomial. My degree, that's my highest exponent, which is 3. And then my leading coefficient is whatever number is in front of that term, which is the 6. So trinomial, degree 3, leading coefficient 6. Let's try another one. I'm going to skip down to this one. Now this one is a little bit trickier. It's x cubed plus 6x plus 8x. But the 6x and 8x, those are like terms. So this is actually like saying x cubed plus 6x plus 8x is 14x. So this is actually only 2 terms, which means it's a binomial. And then my highest degree, again, is the 3. And the number in front of that x cubed, since there's nothing written there, it's like saying there's an invisible 1. So the leading coefficient is just 1. All right, I want you to go ahead and pause this video and fill in the rest of this chart. And while you're doing that, you can look at my cute little gerbil pen. So when you're ready to check, push play. Alrighty, go ahead and check all of your answers. Notice for a few of these, I did rewrite them. So this one I just rewrote so it'd be in standard form and a little easier to find my degree and leading coefficient. This next one I did the same thing. I just rewrote it in standard form. Also note, this one has 4 terms, which means we just call it a polynomial. It doesn't have a special name. And then the last one, I combined that 6x minus x to get 5x, and that also changed it to a binomial. If you hadn't simplified this one, you would have said trinomial here instead. So always, always, always simplify first. Let's go ahead and check out an example now. Now that we understand the different properties of standard form, writing it in the correct standard form, identifying different parts of them, let's actually start adding and subtracting. So this first one, we are adding. So you have a couple of options here. You can either rewrite this whole thing out without the parentheses, or you can just look at your like terms and cross them out as you go. Personally, that's what I like to do when it's addition. So I'm going to look for my highest exponent first. So my highest degree is this x cubed. And I see that I have 2 terms that are x cubed. I have 2 of them, and then I add 1 more. So 2x cubed plus x cubed is 3x cubed. Then my next highest power is the x squared, so negative 5x squared plus 2x squared. So if I have negative 5 and I add 2, I have negative 3x squared. And notice I'm doing just these different colors and underlining just to keep track of what I've used so far. You could also just cross them out as you go if you want. So next one, all we have is an x, and it's the only one. So I'm just going to add x. And then last but not least, I have this negative 1 down here at the end. So notice I showed you both strategies there. I showed you with underlining or just crossing out, whatever makes the most sense to you. And then I'm just going to rewrite this so that it's not in a bunch of colors. Minus 3x squared plus x minus 1. I don't know why it keeps doing that. My apologies. Now you also want to note, always write your answers in standard form. So I'm going to write that little note over here on the side. Always put your answer in standard form. Always, always, always. It's still technically correct if you don't, but if you're being tested on being able to write something in standard form and you don't, you're going to lose points. So make sure you write it in standard form. All right, now we're going to do an example with subtraction. So this one is going to be a little bit different. Instead of just leaving it like this and finding what my like terms are, I need to deal with this minus sign first. This is like saying there's a little tiny invisible negative 1 that has to get multiplied or distributed to everything inside these parentheses. Always, always, always make sure you do that first. So let's rewrite this. First one stays the same, 4x squared minus 3x plus 5. But now I'm distributing this negative. So negative times 3x squared is negative 3x squared. Negative times negative x becomes positive x. And then negative times negative 8 becomes positive 8. Now again, your options here, you can either underline stuff or cross stuff out, whatever your personal preference is. Personally for me, I'd rather underline stuff. My goodness, I don't know why it keeps doing that. Okay, there we go. We're back. So I'm going to underline stuff instead. So the 4x squared is my highest power. So I have 4 of them. and then I subtract 3 of them. So I'm going to have just x squared, 1x squared. And then my next term is the x's. So I have negative 3x, positive x. Negative 3 plus 1 is negative 2x. Then I have, I don't know why it keeps doing this. This is the first time I've used my document camera since break. So I'll check the cords. I don't know what the issue is. My apologies. All right, then the last one is the constants. So positive 5, positive 8. 5 plus 8 is 13. And then just for the sake of making this look nicer when I highlight it, I'm going to rewrite it in just black instead of all the colors. Now, if I were to be doing this to show solutions on homework or doing a quiz or a test, I would go straight from here to here. The only reason I'm writing it out in the colors is so that when you go back and look at it, you understand where this x squared came from, that it came from these 2 green things, that the negative 2x came from the pink things. That's why I'm doing it in the colors the way that I am. All right. Now, per request, there were some people who mentioned that they would like to have more examples in the notes. So I'm going to give you some optional extra practice right now. If you would like to do these problems, go ahead and push pause. And then when you're ready to check your answers, push play. All right, go ahead and check your answers. I did the color coding again, just so you can see it one more time. From here on out, when I do notes and homework solutions, things like that, I'm just going to go straight from here to what's written in black highlighted. A special note about part B, your 3 and negative 3 canceled out and gave you just 0. You do not need to write that plus 0 at the end, which is why I left it out when I wrote the final answer. For this next example, we're going to be finding the perimeter of a couple of different shapes. Now remember, perimeter means, good, you should have said the distance all the way around the outside. Area is the area that's inside. Perimeter is just if you add up all the outside edges. So we have a couple of options for how we can do these. And I also want to point out these little tick marks on the sides. That means that all 4 of these sides are equivalent or equal. They're all the same. So all 4 of these sides are 4x minus 2. So you have 2 options for how you can do this. You can either say, okay, I have 4x minus 2. So I have 4x minus 2. That's one side. Plus 4x minus 2 for the left. Then for the top, plus 4x minus 2. Then for the right side, plus 4x minus 2. And add them all up. 4x, 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 and 4x, which gives us 16x. And then we have negative 2, negative 2, negative 2, negative 2, which gives us minus 8. And I'm going to say units because we are looking for perimeter, but it doesn't tell us if it's inches or centimeters or feet or whatever. Now the other option is if the perimeter is all 4 sides added up and all 4 sides are the same, we can say it is 4 times the distance of one of those sides. And then from there, we can distribute that 4. And we get 16x minus 8. And again, we write units. 2 ways of getting the exact same thing. Now part B is a little bit different. This one is a rectangle. So the different tick marks. 1 tick mark means that left and right sides are the same. Double tick marks means that top and bottom sides are the same. So again, you have 2 options here for how you can solve this as well. We can say, all right, well, this is 5x squared minus 4y plus 3, plus the right side, which is 3x squared plus 2y, plus the top, which will be the 5x squared minus 4y plus 3, plus the left, which will be the 3x squared plus 2y. That's a lot of writing and a lot of room for making mistakes, but let's go ahead and try it out. So on my x squareds, I have 5, 3, 5, 3. So I have 16 of those total. So 16x squared. And then my y terms are next. So I have negative 4, positive 2. That's negative 2 total. Negative 4, positive 2. That gives me a total of negative 4y. And then last but not least, my constant terms, 3 and 3. So 3 plus 3 is 6. And again, we need to write units because it's asking us for a distance, but we don't know what the units are. Now our other option for solving this, can anybody think of what the other option would be? Good, if you said something along the lines of 2L plus 2W, or multiply each side by 2 and add them, anything along those lines, you are correct. So this bottom side, the 5x squared minus 4y plus 3, there's 2 of them. So I can multiply this entire thing by 2. Plus my right and left side, which is 3x squared plus 2y. There's 2 of those also. And then I can distribute. So 2 times 5x squared is 10x squared. 2 times negative 4y is negative 8y. 2 times 3 is 6. And now moving on to the other one. 2 times 3x squared is 6x squared. And then 2 times 2y is 4y. And then for combining our like terms, we have 10x squared and 6x squared. So that gives me 16x squared. And then I have negative, oopsies. Then I have negative 8y and positive 4y, which gives me negative 4y. And last but not least, the positive 6 units. Exact same answer, 2 different ways of getting it. Alrighty, that is the end of our notes, and have a good rest of your day.